Hey everyone, today I will be going over a perfect competition market where we have to find short run total cost, average total cost, we have to find the firm supply function, we have to show quantity demand, and we have to do some graphs. And let's get right into the question. Now, this question in particular is a little bit tricky because you're not given like any sort of total cost. You actually have to derive the total cost yourself. And that's the most important part of the question. And that's the first part of the question. So really pay attention to this first part. And that is finding, it's part A. It's going to be finding the total cost in the short run. So find total cost in short run. How do we do this? Well, let's read the question actually. We should do that first. In a perfectly competitive market, suppose that each identical firm has the following production function: Q is equal to 2 square root KL. Each unit of capital costs 8 units. Each unit of labor costs 2 units, or $2. The level of K is fixed at 16 units. So we know that because K is fixed, we know we're in the short run, right? So let's write some of this down. We know each unit of capital, which we can write as R, is equal to 8. We know each unit of labor costs $2, so we'll write W is equal to 2. Just assume like W is wage, right? And we know that K is fixed at 16. And we denote this by putting a bar on top of K. So we'll say K bar is equal to 16. That means K is fixed at 16. Well, what is total cost really equal to? Well, total cost is equal to the wage times how many workers we have, plus, let's just say, how much each unit of capital cost, times how much capital we have, right? Well, just subbing in our variables, we know that it's going to be 2L plus 8 times 16 is our total cost. But how do we find L? And that's what we're going to do right now. So we have, this is very important. I'm going to write this in blue. I'm going to put a star right here. Q is equal to 2 root KL, right? We can rewrite this as Q is equal to 2 times K to the power 1 over 2 times L to the power 1 over 2, right? We know that K is 16, so we know Q is equal to 2 times 16 to the power 1 over 2, L to the power 1 over 2. We know that 16 to the power 1 over 2 is just the square root of 16, which is equal to 4. So we can write Q is equal to 2 times 4 times L to the power 1 over 2. Okay, continuing, Q is equal to 8 times L to the power 1 over 2. Okay, we're getting somewhere. We have to isolate for L because remember, we don't know what L is in our total cost function, right? So we have to isolate for L. So we'll divide both sides by 8, right? We're going to get Q over 8 is equal to L to the power 1 over 2, or L square root. And now we can just square both sides, right? Raise both sides to the exponent 2. This cancels out the square root in L, and we know that L is just equal to Q squared over 8 squared, which is equal to Q squared over 64. Well, perfect. We found L. We know L is equal to Q squared over 64. So therefore, we can write our total cost is equal to 2 times Q squared over 64 plus 8 times 16. We know the 2 will cancel out here and make this denominator 32. So we know total cost is equal to Q squared over 32 plus 8 times 16, which is, let me get my calculator, 128. And this is our total cost function. As I said, this is the most important part of the question. You need this total cost function for the rest of your question. If you get this wrong, you will get the whole question wrong. So this is really the most important part, right? So if you take away anything from this, just take away how to do this and you'll be fine, right? So if we go back to part A, we found total cost. We can check that off. Now we need to find average total cost, right? We know that average total cost is just equal to the total cost divided by Q, right? It's just what is the total cost divided by the average number of units we produce, right? So in our case, it's going to be equal to Q squared over 32 times 1 over Q plus 128 times 1 over Q, right? We're just dividing both sides by Q. As you can see, the Q here and the Q here cancel out. And we know that average total cost then is equal to Q over 32 plus 128 over Q. All right, perfect. So that is part 2 of question 8 complete. Now we need to find the average fixed cost and the average variable cost. Okay, well, if we go back to our total cost function, right, which is right here, total cost is equal to Q squared over 32 plus 128. We know the average fixed cost. Let me actually just write it down here. We know the average fixed cost is equal to the total fixed cost divided by however many Q units we produce. Well, what is the fixed cost in our total cost function? It's 128. Now, why is it 128? Well, the fixed cost is 128 because it doesn't change with how many units we produce. Whether we produce 10 units or 100 units, it's still going to cost $128. So we know that's the fixed cost. It's not impacted by Q. So we can write this as 128 over Q. And therefore, our average fixed cost is equal to 128 over Q. Perfect. Now we're going to do average variable cost. It's very similar. Average variable cost is equal to the variable cost over Q. Well, if 128 is the fixed cost, then Q squared over 32 must be the variable cost. But why? Q squared over 32 is the variable cost because that cost will change as we produce more or less Q units, right? If we produce 10 units, this number is going to be smaller, this cost, than as opposed to if we produced 100 units. So we know this is just going to be equal to Q squared over 32 times 1 over Q, which is dividing by Q, which is just equal to Q over 32, right? Because the Q's will cancel out. So therefore, we know our average variable cost is equal to Q over 32. Let me just make sure my answer is right. Yes. Finally, we did average fixed cost, we did average variable cost. Now we need to do marginal cost. And that's pretty easy, right? Marginal cost is just equal to the derivative of Q with respect to total cost, which in our case is going to be equal to 2Q over 32 plus 0, right? The derivative of a constant is 0. We know this will cancel out, and therefore we know that our marginal cost will equal to Q over 16, right? And perfect. So we did that, and now it's asking at what output level is average total cost minimized? So find the Q level that minimizes average total cost. Well, we know that in perfect competition, the price is equal to the marginal cost, which is equal to the minimum average total cost, right? We have marginal cost. Marginal cost is equal to Q over 16. And we have the average total cost. It's equal to Q over 32 plus 128 over Q, right? Now we have to solve for Q, right? So we're going to, how are we going to do this? We're going to bring this Q over. We're going to have Q over 16 minus Q over 32 is equal to 128 over Q. We know we have to multiply this fraction, Q over 16, by 2, so we can have the same denominator. So 2Q over 32 minus Q over 32 is equal to 128 over Q. We know then that Q over 32 is going to be equal to 128 over Q. We know we can cross multiply. We'll get Q squared is equal to 128 times 32. Q is going to be equal to the square root of 128 times 32, right? Because we're just going to square root both sides. And just putting this into your calculator, the level of Q, which minimizes average total cost, is equal to 64. Perfect. And that's part A of the question done, right? Let me just write everything nicely. We know that our total cost is equal to Q squared over 32 plus 128. We know that our average fixed cost is equal to 128 over Q. Our average variable cost is equal to Q over 32. Our marginal cost is equal to Q over 16. And Q star is equal to 64. Perfect. Now we can move on to part B. Part B states, find a competitive firm's supply function. If there are 100 firms in the industry, what is industry supply? Let's do that. Well, we know to find the competitive firm's supply function, we know we can just set price is equal to marginal cost, right? And we will get price is equal to Q over 16, right? 16P is going to be equal to Q, right? And that's our firm supply. But there's one more step we have to do, and it's ideal that you do this step before you actually set price equal to marginal cost and find your competitive firm supply. You want to set the marginal cost equal to the average variable cost, right? And in our case, that's going to be Q over 16 is equal to Q over 32, right? When you look at this, there's only one Q that can satisfy this equation, and that's Q is equal to 0, because then you would have 0 is equal to 0. So that's, you would say that the average variable cost of Q is equal to 0 is equal to 0, right? So it costs you 0 when Q is equal to 0. That's the price of the average variable cost. So as long as price is greater than 0, the firm supplies. And let me just contradict what I just said. I'll explain this. As long as price is greater than 0, the firm supplies. Why? Well, if the average variable cost, let's say it's 5, right? Let's say the average variable cost is 5. It cost us $5 to make each unit. If the price is less than 5, we're not going to produce because we're losing money on every unit we produce. It makes no sense. If I'm going to sell a product for $3 and it costs me $5 to make that product, I would lose $2 on every transaction. That makes no sense. I wouldn't supply at that point. This is what we're finding here, right? As long as your price is greater than the average variable cost for the quantity you produce, you supply. If it's less, you don't supply because you're losing money on every single item that you sell. In this case, we got lucky. As long as Q is greater than 0, as long as price is greater than 0, we supply. But definitely do this for other questions because, this might not be the case. You might not get 0, right? So the firm supplies, positive supply, right? We know we set price is equal to marginal cost. We know Q is equal to 16P. Perfect. And then the rest of part B says, if there are 100 firms in the industry, what is industry supply? Well, industry supply is just going to be equal to 100, because there's 100 firms in the industry, times the individual supply of the firm, which is 16P. So we know industry supply denoted by big Q is equal to 1600P. Perfect. And that is question B done, right? We found the individual firm supply function and we found industry supply. Now part C. Suppose that demand function is given by demand of P is equal to 3200 minus 400P. Find the competitive equilibrium price, output of each firm, and industry output level. At the equilibrium price output level, what is economic profit? Is it a short run or long run equilibrium? Why? Okay, let's do that. So I'm going to put part C. The demand of P is equal to, what was it? It was 32,000 minus 400P. Okay. We know that in the perfect competition, we know that profit is maximized when quantity supplied is equal to quantity demanded. That's our equilibrium point, right? We just found quantity supply, it's 1600P, and quantity demand is just given to us. It's 32,000 minus 400P. Well, that makes things easy. We just do some algebra. 2,000 P is equal to 32,000. P is equal to 32,000 over 2,000. P is equal to 16, right? Sorry. 32,000 over 2,000, P is equal to 16, right? We know when P is equal to 16, we know quantity supplied is going to be equal to 1,600 times 16. So we know quantity supplied is going to be equal to 1,600 times 16. Sorry, one sec. Is going to be equal to 25,600, right? We're just going to sub P into QS, right? So we know the price equilibrium is going to be 16. We know that the total output is going to be 25,600. And we can also sub P is equal to 16 into our individual supply function, right? Which is just 16P. Q is equal to 16P. It's equal to 16 times 16. It's equal to 256, right? So therefore, the individual firm supplies 256 units at the price is equal to 16. And the market, because there are 100 firms in the market, right, is going to supply 25,600, right? Again, we know that quantity supply, like market supply, is 25,600. We know there's 100 firms in the industry. If we do the division, we're going to get 256. We can also go the other way, right? We know that each individual firm supplies 256. There's 100 firms in the market. If we multiply these together, we'll get 25,600. So we're making good progress, right? We found the competitive equilibrium price, output of each firm, and industry output level. Now, what is the economic profit, right? Well, the economic profit is just going to be equal to the price minus the average cost times however many units we sell, right? We have the price. We know the price is going to be equal to 16, right? We know we're supplying 256 units, each firm, right? This is for each firm. What's the average cost, right? Well, remember, our average cost, where did I write it? Our average cost is, oh, sorry, I forgot to write it. Our average total cost is going to be equal to Q over 32 plus 128 over Q, right? We know that each firm is going to supply 256 units. So the average total cost at Q is equal to 256 is going to be equal to 256 over 32 plus 128 over 256. The average total cost is going to be equal to 8.5, right? So we'll get 16 minus 8.5. If we plug this into our calculator, minus 8.5 times 256, we're going to get profit is equal to 1920. Perfect. We solved for profit. We're almost done, right? The last thing it asks is it a short run or long run equilibrium? Why? Well, let's do that. We know profit is equal to 1920, right? Which is greater than 0. Therefore, it's a short run equilibrium, because profit is greater than 0. And why is that the case? Well, we know in perfect competition in the long run, profits are always going to be equal to 0, because in the long run, new firms can enter, they'll cut prices against each other, they'll drive the price equal to the marginal cost, equal to the average total cost, which will make economic profit 0, right? That's the key takeaway. In the long run, economic profit is 0 in perfect competition because firms can enter and exit, right? Just think about pencils, right? If I see people making money selling pencils, in the long run, I can make my own pencil business and undercut their prices. And we're just going to keep undercutting each other's prices until economic profit is zero. So that's why we know it's a short run equilibrium, because economic profit is greater than zero. Okay, perfect. Now we're going to go to D. Show the above short run equilibrium on a graph. And you should have one industry graph and one individual graph. Okay, perfect. Let's do it. Right? I'm going to denote the market here, and I'll do the individual, sorry, I can't spell, individual firm here, right? We're going to have our two graphs. Perfect. Perfect. Whoa. Let me fix this actually. Hold on. Okay, that's better. We know on the vertical axis, it's price equal marginal cost equal min average total cost. We know this is Q. We know this is small q. Price equal marginal cost equal minimum average total cost. Let's start with the market, right? Remember, market demand is equal to 32,000 minus 400p. And, sorry. Market demand and market supply was equal to 1600p. Let's start with demand. We have to draw our choke price, and we have to find our intercepts basically. We know that our price choke is going to be equal to the price which makes quantity equal to zero, right? And that's just the vertical intercept is what we're calling it. So how we'll do that is we'll say, okay, 0 is equal to 32,000 minus 400p, right? 400p is equal to 32,000. Divide both sides by 400. P is going to be equal to 80. So we know our choke price is equal to 80. We also know that when the price is equal to 0, right, quantity demanded is going to be equal to 32,000 because there's no price. So we know that here is 32,000. Let me just get rid of these lines. And this first line is our market demand, right? Now, market supply is much easier. The reservation price, which is just what's the quantity when price is equal to 0, we know it's just equal to 0, right? Because when price is equal to 0, quantity is equal to 0. So we know it's 0, 0. Sorry, I made a mistake there. When price is equal to 0, quantity is equal to 0. When quantity is equal to 0, price is equal to 0. And we know this is our quantity supply function. We know we're going to have our equilibrium in the middle. Let me just get a brighter color. We know this is our equilibrium. We know in the market, equilibrium supply is equal to 25,600, right? Perfect. And we know the equilibrium price is going to be equal to 16, right? We already calculated that. We know that each individual firm is a price taker. They take the price that the market gives them. So we know price here is going to be equal to 16, and we can draw this vertical line for price. Perfect. Now, we know that each individual firm supplies 16p, right? Again, so we can draw our individual firm supply line like this, right? We know, let me get another color here, and let me just make sure my graph is right. We know that profit is maximized when the marginal cost is equal to the price, which is equal to the average total cost. So we're going to draw this. Let me actually draw the marginal cost line first. That might be a little bit easier. We know marginal cost is equal to Q over 16, right? So actually, let me get rid of this quantity supply line and replace it with a marginal cost line, right? And then what I can do from there is go like this. Perfect. And we know this is average cost. And then I'm just sorry for the confusion. I'm looking at my graph and it's a little bit confusing. Also, my average cost line is a little confusing. Let me redraw this. Okay, perfect. Average cost. Yes. We know that each firm supplies 256 units, right? And we found that by setting prices equal to marginal cost. So right here, we know this is going to be equal to 256, right? I apologize for the confusion. The graph I'm looking at is very, very compressed, and mine is much bigger. So that's just why I'm getting confused. But we know when price is equal to marginal cost, each individual firm will supply 256 units. Perfect. We know that the average cost when each individual firm supplies 256 units is equal to 8.5. And again, I'm getting in a little bit of trouble with my graph. Let me change my average cost line. Perfect. There we go. Right? So what you can see from this graph is when price is equal to marginal cost, right? When this blue line is equal to the marginal cost line, we're going to produce 256 units, each firm. We know that the average cost at this point is going to be equal to 8.5. We already solved that. We know that average cost is minimized, let me use black here, is minimized when Q is equal to 64. And how do we know that? Well, we solved that in part A, if you remember. Recall, price is equal to marginal cost, which is equal to minimum average total cost, right? Q is equal to 64, right? So we know that average cost is minimized when Q is equal to 64. Well, what's the price at this point, right? We know average cost is equal to, what was it? Q over 32 plus 128 over Q. If we just sub 64 into this, we'll get 64 over 32 plus 128 over 64, and we'll get 4, right? So we know that average cost is 4 when we produce 64 units, and that's the minimum point, right? Perfect. I apologize if that was a little bit confusing. I'm just going to go over this briefly again, not that the graphs are up. We have our market, we have our quantity demanded line, we have our quantity supplied line, and we have price is equal to 16. We know when the price is equal to 16, quantity supplied in the market is going to be equal to quantity demanded in the market, and it's going to be equal to 25,600. We know each individual firm is a price taker, right? So their price is also going to be equal to 16. When the price is equal to the marginal cost, which is equal to average cost, right? We know Q is going to be equal to 256, right? We also know that at Q is equal to 256, price's average cost is equal to 8.5. We know average cost is minimized when Q is equal to 64, and the price is equal to 4. Perfect. What's our profit? Our profit is this little area right here, right? Because if you remember, our profit was 16 minus 8.5 times 256. Perfect. That is part D done. I apologize if that was a little bit confusing. But we're going to do more graphs, so don't worry. Now, E says, suppose that the fixed cost of the firm is compatible with long run, it exists even in the long run, and the industry is a constant cost industry. What will happen in the long run to reach equilibrium? Explain by showing the long run adjustment process on a graph similar to part D. Let's do it. Let's do part D. All right. So we're going to draw our graphs again, and we're going to show it in a little bit less detail, if you will, but you still want to label everything, right? Let me get to here. Perfect. We know we have our quantity demanded line, 32,000, our choke price of 80. We have our quantity supplied line, right? And we know our equilibrium is 25,600. And the price is equal to 16, right? And in our original graph, we know this is going to be marginal cost. We know we can trace price over here, right? Price is equal to 16. And we know we're going to have our average cost line like this. We know at this point Q is equal to 256. Price is equal to 16. The average cost is equal to 8.5. Remember, we did this earlier in the question. Average cost is minimized when Q is equal to 64 and price is equal to 4. Right? Now, what happens in the long run? Well, in the long run, right, more firms are going to enter the industry, so N is going to increase because there's economic profit. As N increases, quantity supplied increases, right? As quantity supplied increases, the price decreases, and the price is going to decrease to the price where average cost is minimized, and it's going to drive economic profit equal to 0, right? How can we show this on the graphs? Well, we can trace this average cost of 4 back into our old graph, and that's how much we're going to shift quantity supplied by. We're going to have our new quantity supplied line. Let me just move it around a little bit. Quantity supplied 2. We know it's an increase. We know quantity supplied shifts to the right. We know this is our equilibrium new. We know this is our equilibrium old. And then we know quantity demanded at this point is going to be equal to 32,000 minus 400 times 4, which is equal to 30,200. And this is our new graph, right? And the last part, this is not part D, this is part E, sorry. Part F says, what's the long run equilibrium price? Output in number of firms. What's the profit per firm, right? Let's do it. Well, we know the long run price long run is going to be equal to 4. Why is it going to be equal to 4? Well, we know that in the long run, profit's going to be equal to 0, right? What is profit really? Profit is equal to price minus average cost times Q, right? So profit is equal to price minus 4, because we know the average cost is 4, times 64. We know we supply 64 units when average cost is minimized. Well, in order to get this to 0, price has to be equal to 4, right? Because profit's going to be equal to 4 minus 4 times 64. Profit's going to be equal to 0 times 64. Profit's going to be equal to 0. So therefore, we know price in the long run is equal to 4. We know average cost is minimized when Q is equal to 64. So we know Q long run is going to be equal to 64. Profit's going to be equal to 0. And the new number of firms in the market is going to be equal to 3,200 over 64, which is, sorry. We know QS is equal to 1600P. So we know QS is going to be equal to 1600 times 4. It's going to be equal to 6400. We know each firm supplies 64 units. This is not right, sorry. Sorry. I made a mistake here. Forgive me, I'm a little rusty on the subject. We know quantity demanded is 32,000 minus 400 times P equal to 30,200. We know N is going to be equal to 30,200 over 64. N is going to be equal to 475. Sorry, I made another mistake. This is actually equal to 400. I also made this mistake here. And we know that N is going to be equal to 475, right? Because N is equal to big Q over little q. And that's how we solve this question. The graphs were a little bit confusing. I do apologize for that. But as long as you know what you're talking about and you show what you label, you'll be fine. And again, knowing the graphs comes from understanding the equation. So you really have to understand the first half of this question to understand the second half of this question. And you really have to understand this first part, right? Finding total cost. Because if you can't find total cost, you're going to lose marks for the whole question. Thank you for tuning in.